In this question, we've got Margaret investing on the 1st of February 1993, and she puts $5,000 in the account. So she starts with $500,000, $5,000, not 500,000. It's paid at 6% per annum, and it's compounded annually. So that the interest and the rate is not too bad. So first part is how much would be in the account after the payment of the interest on 1st of February 2003. So if we look at how long she's gone, so it's been 10 years, and it's 1st of February 1993 to 1st of February 2003 with no additional payments. Basic, simple compound interest question. So 5,000 outside the 1 plus the 6% to the power of 10, because it's been 10 terms, amounts to that amount. So that's just applying compound interest. Now, what is in fact happening is that on top of that $5,000 that Margaret invested on 1993, she adds $500 to her account on the 1st of February each year, beginning in 1st February 1994, and then she does that up until the 1st of February 2003, and then how much is in it immediately after she puts that last deposit in. It's a bit different again, this question. And so you really got to start to understand what's happening. When's the amount being put in? At what time? Does it get interest? How much interest does it get? So we've got to be really careful. So if we have a look at setting up our problem. So again, at the end of the first year, what she does, she's had that $5,000 in for 1 year, because that's the original $5,000. It's been invested in 1993. So at the end of we look at the end of the first year. I'm saying the end of the first year. Really, it's the start of the second year as such, because we're looking at the first of February. This is at the point of 1st of February 1994. She puts in that next $500. 5,000's had 1 year of interest, and she puts in $500. So, and then the end of the second year, that amount that she put in has interest applied to it. And again, but then she puts in another $500. So notice our pattern's looking a little bit different. Our 5,000 to the power of 1.06 squared is sort of separate this time. It's just going up. It's just one-off amount. But now our $500 only had one investment payment on it, and the second $500 at this point has not got anything, because this is at basically 1st of February 1995. So 1st of February 1996. So there's our original 5,000, and then we start to see our pattern setting up. So that's the amount from 1994, 1995, and that's now the payment from 1996. So if we jump through to 1st of February 2003, there's the amount from part 1, where we've calculated all that. So that's just separate. But then here's the $500 that have been invested, and this is the $500 invested at 2003. So it hasn't gained any interest, because we're talking, this is the amount is there at the 1st of February 2003. So it hasn't gained any interest at all. So again, our pattern's going to look a little bit different. If we take all this amount and change it all around, so I've got my $500 I'm going to take out, and then that's going to leave me 1, because that's that $500 there being factorized out. There's the 1.06, and then 1.06 squared, up until the 1.06 to the power of 9. So there's my pattern this time. So looking a little bit different, because the way the question's structured, because we're going to invest $500, but not gain any interest. So that's why it's that we get that 1 there, because it hasn't gained any interest there. So this time, if we have a look at our pattern, we've got A is 1, R is 1.06, because it's going up by 1.06 each time. But again, we've made 10 investments. We start at 1, but then we go 1.06 power of 1 up to 1.06 power of 9. If you're not sure, you can write them out to check this out. But there's 10 payments that have been made. Okay, from 1994 all the way through to 2003. The 5,000 is separate because it's not part of this pattern. It's only this part of the pattern there, but there's still 10 terms. Again, don't just look for the 9 and go, oh, there's 9 terms. You would be out. And there's lots of cases where these questions are out because people don't get the right number of terms. So what we do now, we set up our sum of a geometric progression. We just add the 5,000 times the 1.06 to the power of 10 on. We can throw it all in the calculator once we've got that to come up with our answer. So be really careful of how many terms, you know how many terms. If you understand what the question's asking, you shouldn't go too far wrong because you'll understand how many terms there are to calculate. So this time in this question, Alex has got $75 into a superannuation fund beginning of each month. Again, interest is compounded monthly. So interest is per annum, but it's compounded monthly. It's paid at the end of each month. So this one's more regular type of situation. Find the value of the fund at the end of 5 years. So we need to set up our terms first. P is going to be 75. The rate of interest per month is 15 on 12. So 15% divided by 12, because that's per month, as a percentage comes out as a decimal as 0.0125. And then because he's doing it for 5 years, but every month, he gets 60 terms. The more terms you have, the better it is, because the more it compounds. Compound interest is nice like that. So at the end of the first month, he's had $75, and it's been invested at 1.0125. So there's our 15% per annum divided by 12, added to 1 to the power of 1. So that's the amount at the end of the first month. He puts another 75 in at the start of the second month, and at the end of the second month he's had interest applied again, so he expanded out. I'm pretty confident in my pattern to say, well, after 60 months, that first amount there has been compounded 60 times. The second amount there has been compounded 59 times, and right down to the last month, which was only compounded once. So there's my pattern. I'm going to factorise my 75 out and rearrange my terms. So I see my nice geometric progression. R is going up by 1.125, and then we've got 60 terms because I invested 60 amounts. Put it into the calculator, and that's what it's come down to. So that's the amount at the end of 5 years. So how many months will Alex needs to compute if he wishes to fund to be worth $40,000? So this time's a little bit different. So we've got our formula, but what if it wasn't just 60 months? What if it was n amount of months? So if that's the case, our pattern would be exactly the same as what we saw over here, except it'd keep going through till we get to n. So we'd have an unknown amount of months. And so all I'm going to do is take our sum of GP that I had, and I'm going to use the value of n there, and that's going to be equal to 40,000. Now, the only unknown I've got here is n. So what we're going to do, we're going to clean this up, divide it by 75 on both sides, multiply. You can do your calculation here and divide by that amount. So, or you can multiply by this amount and then divide by that amount. It's up to you which way you do it. And leaves me with this amount here would be equal to 6.58, and it's going to keep going on your calculator, which means the 1.0125 to the power of n would equal 7.58. So keep that in your calculator, don't round it off. So, but you should see something like that on your calculator. Now what I'd need to do is find the value of n, which means by using logarithms, I can set it up this way. So the definition of a logarithm would have n, so the power there would be equal to log of the base, equal to, and we're taking the logarithm of that number, the 7.58 ... Okay, so remember, I can't do it this way. I need to use a change of base because I need to go to a logarithm that I have on the calculator. So log base 10, you could use either buttons on your calculator, doesn't matter. So log of 7.58 that we had there, so keep that answer in your calculator as you go through. Divide that by log of 1.0125, and that's approximately going to equal 163.09. So again, it's going to go off. What we're more interested in is the 163. So to get 40,000, he's got to invest a little bit more than 163 months. So that means after 164 months, he's going to have the $40,000, over $40,000. So that's how many months you've got to invest for, 164.